Great day, learners! Welcome to the second part of this week's lesson. For this session, we will solve problems involving linear equations in two variables. What are you waiting for? Grab your pen and paper, your self-learning modules, or your compendium of notes, and together, let's rock math. Before we proceed to our topic, let's have a quick recall. From the previous weeks, we have learned about linear equations in two variables, wherein the standard form of linear equations in two variables is ax plus by is equal to c, where a, b, and c are constant and a and b are not equal to 0. Now, let's use this skill to solve problems involving linear equations in two variables. Let's have problem number 1. The sum of two numbers is 15. The difference of the same two numbers is 7. What are the two numbers? Just like any problem, we will also follow a step-by-step procedure to solve this. In this case, our first step is to define the variables. From our problem, it is clear that we are looking for two numbers, and these two numbers are not equal. Therefore, there exists a smaller number and bigger number. With that, let y be the smaller number and x be the bigger number. After defining the variables, let's establish our system of equations. From the first part of our problem, it says there that the sum of two numbers is 15. Our two numbers is x and y. Therefore, if we add them, the result will be 15. So our first equation will be x plus y equals 15. And next, we have here the difference of the same two numbers is 7. Meaning, if we get the difference of x and y, the result will be 7. Therefore, the second equation will be x minus y equals 7. Our third step is to solve the system. We have here our two equations. X plus y equals 15 and x minus y equals 7. If you can notice, we can easily eliminate y since they have opposite signs. The first is positive y and the second is equal to negative y. We can simply add these two equations. X plus x equals 2x. Y plus negative y is equal to 0. 15 plus 7 equals 22. Now, let's solve for x. In order to do that, let's divide both sides by 2. 2x over 2 equals x and 22 over 2 equals 11. Therefore, x is equal to 11. Since we already solved for the value of x, this time let's solve for y. Let's get one equation from our system of equations. For this one, let's have x plus y equals 15. Since we already know the value of x, we can substitute it, and then it becomes 11 plus y equals 15. Let's isolate y and put 11 on the other side of the equation, and it becomes y equals 15 minus 11. We simplify, y equals positive 4. Therefore, the numbers that we are looking for are 4 and 11. Let's have another problem. We have here problem number 2. The sum of two-digit number is 11. The tens digit is 1 more than 4 times the unit digit. Find the number. In this problem, how many numbers are we looking for? We are only looking for one number, a two-digit number to be specific, and we need to determine the units and tens digit. Now, let's define the variables. Let y be the units digit and x be the tens digit. After defining the variables, let's establish our system of equations. From the first part of our problem, it says there that the sum of a two-digit number is 11. Meaning, if we add x and y, we get 11 as the result. Therefore, our first equation will be x plus y equals 11. On the second part of our problem, it says there, the tens digit is 1 more than 4 times the unit digit. We can generate the equation x equals 4y plus 1. Now this equation, we can transform this into an ax plus by is equal to c form. Therefore, we get negative x plus 4y equals negative 1. Our third step is to solve the system. We have here our two equations, x plus y equals 11 and negative x plus 4y equals negative 1. If we can notice, we can easily eliminate x as they have opposite signs. The first is positive x and the second one is negative x. We add these equations, x plus negative x is equal to 0, y plus 4y is equal to 5y, 11 plus negative 1 equals positive 10. Now, let's solve for y. We divide both sides of the equation by 5. We have here 5y over 5 is equal to 10 over 5. We simplify, y is equal to 2. Now that we already solved for y, this time let's solve for x. We get one equation from our system of equations. This time, let's use x plus y equals 11. We already identified the value of y. Therefore, we can use this value to substitute in our equation. So it becomes x plus 2 equals 11. Let's isolate x by putting 2 to the right side of the equation. So it becomes x equals 11 minus 2. We further simplify, x equals 9. Therefore, the units digit is 2 and the tens digit is 9. And the number that we are looking for is 92. Let's have problem 3. 10 years from now, Jaden will be 3 times older than he is today. What is his current age? Again, our first step is to define the variables. Since we're looking for Jaden's current age, we represent x as his current age. Now, let's establish the equation. Going back to the problem, it says there that 10 years from now, Jaden will be 3 times older than he is today. That is why we generated x plus 10 equals 3x. X plus 10 represents 10 years from now. Since we do not know Jaden's current age, we just added 10 and x. And on the right side of the equation, we have 3x. 3x represents 3 times older than he is today. Now, let's solve for the system. We have here our equation, x plus 10 equals 3x. In this case, let's just combine like terms. So, we put x on the right side of the equation and it becomes 10 equals 3x minus x. We simplify, it becomes 10 equals 2x. We solve for x by dividing both sides of the equation by 2. We get 2x over 2 equals 10 over 2. We simplify, x is equal to 5. Therefore, Jaden's current age is 5 years old. Problem 4. 4 years ago, Jest was 6 times as old as his son. 6 years ago, his age was 2 years more than 8 times his son's age. How old are they now? Let's define the variables. In this case, we can use a table to represent our variables. On the first column, let's have their age now. So x is the age of Jest now, and y will be the age of his son. On the second column, we can represent their ages 4 years ago. We can just subtract 4 on the current age of Jest, so it becomes x minus 4. Same goes with his son. We subtract 4 to his current age, so we have here y minus 4. On the third column, let's have their ages 6 years ago. We subtract 6 on the current age of Jest, so it becomes x minus 6, and we also subtract 6 on the current age of his son, So we have here y minus 6. This time, let's establish the system of equations. On the first part of the problem, it says there that 4 years ago, Jest was 6 times as old as his son. Therefore, we can generate x minus 4 is equal to 6 times y minus 4. We simplify it by distributing 6. So we get x minus 4 equals 6 times y equals 6y, and 6 times negative 4 is equal to negative 24. We put constants together and we put the terms with variables together. Therefore, on the right side we have x minus 6y, and on the right side of the equation we have negative 24 plus 4. We further simplify, we have x minus 6y equals negative 20. Therefore, the first equation is x minus 6y is equal to negative 20. The second part of the problem says, 6 years ago, his age was 2 years more than 8 times his son's age. Thus, we have generated the equation x minus 6 equals 8 times y minus 6 plus 2. X minus 6 represents the age of Jest 6 years ago, which is equated to 8 times y minus 6 plus 2, which is the representation of the phrase 2 years more than 8 times his son's age. Now, we simplify the equation by distributing 8. We have x minus 6 equals 8 times y equals 8y. 8 times negative 6 equals negative 48 plus 2. Now, we put all the terms with variables on the left side of the equation and the constants on the right side of the equation. We get x minus 8y on the left side and negative 46 plus 6 on the right side of the equation. We combine negative 46 and 6. We have x minus 8y equals negative 40. This time, let's solve for the system. We have here our equations x minus 6y equals negative 20 and x minus 8y equals negative 40. We can choose to eliminate x more than y as it will be easier for us. Let's change the sign of x in the second equation by multiplying the whole equation by negative 1. So we get negative 1 times x minus 8y equals negative 40, and we simplify it becomes negative x plus 8y equals 40. Our new equations will be x minus 6y equals negative 20 and negative x plus 8y equals 40. We can eliminate x by adding these equations. X plus negative x equals 0. Negative 6y plus 8y equals 2y. Negative 20 plus 40 equals 20. Now let's solve for y by dividing 2 on both sides of the equation. We get 2y over 2 equals 20 divided by 2, and that will result to y equals 10. We already solved for the value of y. This time, let's solve for x. We choose one equation from the system of equations. Let's get x minus 6y is equal to negative 20. Since we already determined the value of y, let's substitute it in the equation. We get x minus 6 times 10 equals negative 20. We simplify, it becomes x minus 60 equals negative 20. Let's put negative 60 on the right side of the equation, so it becomes x equals negative 20 plus 60. We add negative 20 and 60, we get 40 as the value of x. Therefore, Jest is 40 years old and his son is 10 years old. Let's have problem number 5. The length of a rectangle is 15 cm longer than its width. When its width is increased by 3 cm and its length is decreased by 5 cm, the area of the new rectangle is 20 cm squared bigger than the original rectangle. Find the dimensions of the original rectangle. Let's define our variables. Let's use a table to represent the values of the original and modified rectangle. On the first column, we have here the dimensions of the original, wherein L will represent length and W will represent width. On the second column, we have here the dimensions of the modified rectangle. In the problem, we decrease 5 centimeters in the length, so we will use L minus 5. And on the other hand, we increased 3 centimeters on width, so we will use W plus 3 to represent it. Our second step is to establish our system of equations. On the first part of the problem, it says there that the length of a rectangle is 15 cm longer than its width. Therefore, we can generate it or represent it as L equals W plus 15. For our second equation, it says there that if we get the area of the modified or new rectangle, the result will be 20 cm squared bigger than the original rectangle. Therefore, we get L minus 5 times W plus 3 equals LW plus 20. We will simplify this using the FOIL method. L times W equals LW, L times 3 equals positive 3L, negative 5 times W equals negative 5W, negative 5 plus 3 equals negative 15 is equal to LW plus 20. Now, let's combine like terms. We have LW minus LW plus 3L minus 5W is equal to 20 plus 15. We further simplify, we get 3L minus 5W is equal to 35. Our third and last step is to solve for the system. We have here our equations L equals W plus 15 and 3L minus 5W equals 35. If you can notice our first equation, L equals W plus 15, we can actually use this to substitute the value of L in our second equation. Then we get 3 times W plus 15 minus 5W equals 35. We distribute 3, we get 3W plus 45 minus 5W equals 35. We combine 3W minus 5W, we get negative 2W plus 45 equals 35. Let's put 45 on the right side of the equation. It becomes negative 2W equals 35 minus 45. We simplify, we get negative 2W equals negative 10. Let's solve for W by dividing both sides by negative 2. We have negative 2W over negative 2 is equal to negative 10 over negative 2. We simplify, W equals 5. We already solved for the value of W. This time, let's solve for the value of L. From our system of equations, let's choose one equation. In this case, let's have L equals W plus 15. Since we already determined the value of W, we can use this to substitute in our equation. Therefore, it becomes L equals 5 plus 15. We add 5 and 15, we get 20 as the value of L. Therefore, the dimensions of the original rectangle are 20 cm by 5 cm. Problem 6. John and Philip, who live 14 miles apart, start at noon to walk toward each other at rates of 3 meters per hour and 4 meters per hour respectively. After how many hours will they meet? Let's define our variables. Let x be the time walk, and then let's use a table to clearly define the variables for both John and Philip. The second column represents the rates of John and Philip, which is 3 and 4. T represents the time, which is unknown for both John and Philip, so we have here x and x. D represents the distance, which is the product of rate and time. So 3x will represent John and 4x will represent Philip. Our second step is to establish our system of equations. This time we just simply add the distance of John and Philip, wherein we get 3x plus 4x equals 14. Our third and last step is to solve for the equation. We have here 3x plus 4x equals 14. If you can notice, we can combine 3x and 4x because they are like terms. Therefore, we have 7x equals 14. Now, let's solve for x by dividing both sides of the equation by 7. We have 7x divided by 7 is equal to 14 divided by 2. We simplify, x equals 2. Therefore, John and Philip will meet in 2 hours. Ray has 20 ounces of a 20% salt solution. How much water should he evaporate to make it a 30% solution? Let's define our variables. In defining our variables, we have to set up a table for water. The water is removed from the original solution. 20% of solution means 80% of water, and 30% of solution is equal to 70% of water. Let's have our table which clearly specifies the values for the original, removed, and result. The water in the original is 80%, which is also equal to 0.80. The amount is 20, and we multiply it, we have 0.80 times 20. Under remove, the water is 100%, which is also equal to 1. The amount is y, and we add 1 plus y. On the result, we have 70% as the value of water, which is also equal to 0.70. For the amount, we get the difference of 20 and y. So we have here 20 minus y. And we multiply that, we have 0.70 times 20 minus y. Now for our second step, let's establish our system of equations. For this one, we just get the difference of the original and removed. Therefore, we get 0.80 times 20 minus 1 plus y is equal to the result, which is 0.70 times 20 minus y. Our last step is to solve for the system. We have here our equation 0.80 times 20 minus 1 plus y equals 0.70 times 20 minus y. We simplify. 0.80 times 20 is 16. We distribute negative. Negative times 1 equals negative 1. Negative times positive y is negative y. On the right side of the equation, we also distribute 0.70. 0.70 times 20 is equal to 14, and 0.70 times negative y is equal to negative 0.7y. Now let's put all the terms with variables on the left side of the equation and all the constants on the right side of the equation. With that, we get negative y plus 0.7y equals 14 minus 15. We simplify, we get negative 0.3y equals negative 1. Let's solve for the value of y by dividing both sides of the equation by negative 0.3. We get negative 0.3y divided by negative 0.3 is equal to negative 1 divided by negative 0.3. We simplify, we get y equals 3.33 or 10 over 3. This means that we need 3.33 ounces of water should be evaporated. Andre can paint the wall in 40 minutes, and Andrew can paint the wall in 60 minutes. How long will it take for them to paint the wall together? Let's define the variables. Since what is asked is how long will it take for them to paint the wall together, meaning we're looking for the time. Therefore, let x be the time to paint the wall together. Now, let's establish the system of equations. We can use the formula 1 over 40 plus 1 over 60 is equal to 1 over x. 40 came from the time of Andre, which is 40 minutes, and 60 came from Andrew, which he can paint the wall in 60 minutes. Now let's solve for the system. Our equation is 1 over 40 plus 1 over 60 is equal to 1 over x. Since we have here fractions, Our first step is to get the LCD of 40 and 60, which is 120, and we multiply the whole equation by 120. We have here 1 over 40 plus 1 over 60 equals 1 over x times 120. We simplify or we distribute 120. We get 120 over 40 plus 120 over 60 equals 120 over x. We further simplify. 120 over 40 is equal to 3. 120 over 60 is equal to 2. And on the right side of the equation, we have 120 over x. We cross multiply. 3 plus 2 equals 5 times x. We get 5x equals 120. Let's solve for x by dividing both sides of the equation by 5. 5x over 5 is equal to 120 over 5, or x equals 24. Therefore, the time taken for both of them to paint the wall together is 24 minutes. And that is it for solving problems involving linear equations in two variables. I hope that you have learned a lot from this session. Keep practicing and keep improving. This has been Teacher Mark saying that math matters.